Okay, so we are going to look at solving trig equations using inverses. So I have three graphs on here. I have the inverse sine graph. So remember, to find an inverse, we switch places with x and y and solve for y. So if you pull up the sine graph, which I know you have in your notes, if we look at the sine graph, I'm just going to sketch it down here real quick off the unit circle. We know that the sine graph does that, and the top goes from 1 and the bottom goes all the way down to -1, and the period is 2 pi. But we need the inverse to be a function, and it has to pass this function, y equals sine x, has to pass the horizontal line test for its inverse to be a function. Well, if I just draw horizontal lines, it's not going to pass that test. So we restrict the sine graph between pi over 2 and negative pi over 2. So we're going to draw a box here. This is all you're going to be able to see of the inverse function. Then we're going to switch places with x and y. So you can see on my blue graph up here that I've switched places with x and y. So this point where on this graph was pi over 2, 1, is now 1 pi over 2. And this point that was negative pi over 2, -1, is now -1 pi over 2. And then I switch places with all of the other ones, and I get this inverse sine graph. Okay, so here's what that means. My domain for inverse sine is between -1 and 1. My range is between negative pi over 2 and pi over 2. So when we are solving equations in just a little bit, and they're asking us to find the inverse sine, both of these are going to come into play, and I'll explain that in just a minute. Let's go through the other graphs. So inverse cosine, same idea, has to pass the horizontal line test. Remember, cosine starts at 1 and then goes down to -1. So our restriction on this one is between 0 and pi. So cosine at 0 is 1, so you can see that here, 1, 0. And then cosine at pi is -1. So -1 pi when I switch places with x and y. And then those are connected. So that's the inverse cosine graph. Remember, inverse, we can tell the difference between like y equals cosine x by the equation and y equals cosine inverse by that -1. It means inverse. And then for tangent inverse, remember we had vertical tangent lines for vertical asymptotes, sorry, not tangent lines, vertical asymptotes for tangent at pi over 2 and negative pi over 2, and then my tangent graph did this. Well, you could kind of flip your screen. Looks a little similar. As my vertical tangent lines become horizontal tangent lines at pi over 2 and negative pi over 2, and then my graph is positive and then negative. So that's the inverse tangent graph. Domain is all real numbers. Range stays between negative pi over 2 and pi over 2, and notice these are parentheses on this one because those are horizontal asymptotes and it's not going to cross those. All right, so let's talk about what this means when we're solving trig equations. So if they're asking me, and you'll need your unit circle for this, so if they're asking me for sine inverse of square root of 2 over 2, it's asking me a previous question, what is sine theta, or what is theta, what is this angle measure whose sine is square root of 2 over 2? So when we were solving right triangle trig equations, we took sine inverse of both sides to get rid of sine, and then we did sine inverse on this side. So we had theta equals sine inverse of the square root of 2 over 2. Well, we're skipping that solving step. They're just giving us this now, but same type of problem. Okay, so here's what that means. Where on the unit circle, because we see square root of 2 over 2, it's on the unit circle. Where on the unit circle do I have an angle measure whose sine is square root of 2 over 2? So if you look on the unit circle, it actually happens in two spots. At 45 degrees, there's a point square root of 2 over 2, square root of 2 over 2, And at 135 degrees, there's a point, negative square root of 2 over 2, positive square root of 2 over 2. That positive square root of 2 over 2 for the y value is what we care about because we're talking about sine. However, the range for sine inverse, which means the number that's right here, the number that I can plug in right here, the domain, has to be between negative 1 and 1. That's great, it is. The range, the number that it spits out, has to be between negative pi over 2 and pi over 2. So on my unit circle, it means sine inverse is defined in quadrants 4 and 1. So I don't need quadrant 2 for sine inverse. I'm only going to give pi over 4 as my answer, or 45 degrees. So pay attention to what the questions are asking. If they want radian, then type in pi over 4, which they probably do. All right? Okay, let's talk about cosine. Cosine is defined for the range between 0 and pi, which means quadrants 1 and 2. So if it asks for cosine inverse of negative 1/2, I know I could be in 2 or 3 because cosine's negative in those quadrants, but I'm not going to be in 3 because cosine is defined in 1 and 2. Positive values will be in 1, negative values in 2. So I go to quadrant 2, I look on my unit circle, what x value gives me, what angle gives me an x value of negative 1/2? Well, that would be a 60-degree reference angle or pi over 3 reference angle, and so that gives me 2 pi over 3 for my angle measure, or 120 degrees if I want a degree measure. All right, tangent, similar. Tangent's going to be in 1 and 4. So that tells me my range here. So 1 and 4 for tangent. So very similar to sine. Same spots, just can't be at pi over 2 or pi over 2. Okay, another thing to note. If they ask you for cosine or cosine inverse or sine inverse of a number that's larger than 1 or smaller than negative 1, it's undefined. There's no solution. Because remember, cosine and sine, the domain is between negative 1 and 1. In the range on the cosine and sine function, so the range for cosine and sine, so there's sine, here's cosine. Remember, my range is between 1 and negative 1, between 1 and negative 1. So on my inverse, that's my domain, which means I cannot have a number larger than 1, that would be up here. I cannot have a number smaller than 1, that would be down here. Can't have it. Okay, so pay attention to that if they ask you a question like that. All right, last thing. Let's say that they want us to, well, maybe 2 more things. If they have something like this, cosine inverse of cosine of pi over 8. All right, so here's the deal on this. We know that for cosine inverse, we have to stay in quadrants 1 and 2. All right, so that's a thing to think about. Where am I supposed to stay? Like sine, I stay between quadrant 4 and quadrant 1. Cosine 1 and 2. So pi over 8 is in quadrant 1, and they're asking me for an angle theta whose cosine is pi over 8. This is asking me for the angle that gives me, oops, that's not adjacent, that gives me this adjacent over hypotenuse. So these cancel out, basically. They undo each other. So my answer is pi over 8. The thing that we have to be careful of is if we're going back and forth between the quadrants. Okay, so if that's confusing and as you're working problems, if that doesn't make sense, you're welcome to email me. Or when I see you again, we'll talk about it. All right, last one. 6 sine theta equals 3 sine theta plus 2. All right, we are going to solve this equation. So your goal is to get all the trig stuff together on one side, all the numbers on the other side. All right, so I'm going to subtract First, I'm going to move this up. See if it'll let me. All right. First, I'm going to subtract 3 sine theta from both sides. So I have a positive 6 sine theta minus 3 sine theta. That leaves 3 sine theta equals 2. I'm solving for sine theta because I'm going to take sine inverse in just a second. So sine theta equals 2 over 3. All right, so sine theta equals 2/3. Now I'm going to apply sine inverse to both sides of this equation. So sine inverse of sine theta equals sine inverse of 2/3. Forgot the negative one. Okay, so I've applied that to both sides. Well, cool thing about the left side, sine inverse of sine, just like we saw cosine inverse of cosine, gives me theta. And so now I have theta equals sine inverse of 2/3. Okay, we're going to put this on our calculator. If you don't have your calculator, that's okay. Go to desmos.com. When you go to the graphing calculator, it will already be in radian mode, which is great. If the instructions say switch to degree mode, click on the little wrench and change it to degree. But most likely it will ask for radian. So we'll just type this in, sine inverse. So to get this exponent, it's shift 6. And then put the -1 in, but you can also click on the function keyboard, and then function on the right side and find sine inverse. So when you do that, it's going to give you an answer in radian, not with pi in it. Pi will already be evaluated at 3.1415, and so we will round this. So it'll be about 0.73 or 73 hundredths of a radian. All right. So that's how you work those type of problems. Your assignment is on Savas, but you can get to it through Canvas. So you just click on the link, try the problems. There's some helps on there, but you're welcome to email me with any questions. All right? I will see you guys soon.